So here we're going to give an example of the lever rule using this very nice diagram from John Winter's Igneous and Metamorphic Metrology textbook. So we have the Plagioclase binary here, and we're going to use this example here where we have a bulk composition A, and I'm going to show that, I'm going to highlight it with this blue vertical line, and then we have this composition that connects D and F at a temperature of 1450 degrees. So what about bulk composition A? What we know is that for A, it'll be completely liquid at this temperature here, which is about 1470. It'll be completely solid at temperatures below about 1340 degrees or so. Anything in between 1340 and 1470, it'll be a mix of solid plus crystals. So what would be that mix if we were at this temperature of 1450, represented by these letters D and F? Well, we can use the numerical values of the composition of D, the composition of the bulk composition A, and then the composition of the crystals over at F. So A has a bulk composition of AN60. So what we want to do for the lever rule is that we're going to look at the size of this lever here divided by the total length of this line D2F. Now, for this line over here will give us the amount of liquid. How do we know? If you ever forget, just think about the case where it's completely liquid. And so it's a little bit anti-intuitive because we're looking at the part of the line segment that connects F to the solidus. But if you go to 1450 degrees, where we know the system is completely liquid, notice that this dashed curve BC is entirely to the right of the bulk composition. If we come down to H at 1340, we know the composition is completely solid, and so this dashed line G to H is completely to the left side of the bulk composition. So in this diagram here, just by that little intuitive trick, we can always know that for this particular setup, it'll be different for a different setup. It could be different than over here. Everything on the left is going to tell us about the solid. That's 100% solid there. And everything over to the right, the lines on the right are going to tell us about the liquid. So if we look at this segment D through F, everything from A to F is going to be the liquid part, and everything from D to A will represent the solid part. So what is the length of A to F? Well, A is at 60, F is at about 81. So for the composition, that difference is 81 minus 60, and that is equal to 21. And then if we look at the distance from A to D, D is at about 46, so the distance from A to D would be equal to 60 minus 46, and that's equal to 14. So the distance of our liquid lever, so 21 is the liquid lever, and 14 is equal to the solid lever. To get the proportions, we need to compare these, 21 and 14, to the total distance D to F. And the total distance D to F would be 81 minus 46, and 81 minus 46 is equal to 35. So that's the total lever length. So for the fraction of crystals, the percent crystals in the system, we'll write as a fraction first. That would be our solid lever 14 divided by the total lever 35. And 14 over 35 is equal to 0.4. So that is equal to 40%. So we have 40% crystals. And then for the amount of liquid, the percent liquid is going to be equal to the liquid lever, which is 21, divided by 35. As a fraction, that is 0.6. and so that comes out to 60% liquid. So for this particular case of a system that is sitting at 1450 degrees centigrade, represented by that dashed line that goes from D to A to F, we have a system that is at 40% crystals and 60% liquid according to the lever rule.